So it's good. If you remember when we discussed the problem statements, we said that one of the first things you need to do is to define where your task falls under. Whether it's regression, classification, clustering, segmentation, and the likes. So if your task is classification, linear regression is not used for classification. So that's why you have bad results, or it will throw up an error. That's why. So when you're talking about classification, you have logistic regression. Logistic regression is the closest. Logistic regression is like the linear regression of classification. It's built on the linear regression. I will show you how it works. So it's good to identify. So how does the logistic regression work? You see the way we explain linear regression? In a way, that's how it's similar to SVM, support vector machine. Support vector machine is a classification algorithm. We are going to see it. Support vector machine still tries to get that line of best fit, but it uses it in classifying. It uses it in classifying points. Just like say, clustering is for bringing points together, but while classification, you are trying to separate them effectively into different groups. So it's similar to how SVM works. So how does logistic regression work? Logistic regression is the way it works. After getting the line of best fit, you have points. You know, if you use this to predict, maybe this is between maybe 1 to 5, 1, 2, 3, 4, 5. And maybe this is 2 down to 20. And you want to use this now. Let's say this is house price. Oh no, let's use, say this is blood pressure. And this task now, if you want to use this as prediction, it can fall under, okay, so maybe I want to predict based on, let me just use something random, BMI. I want to predict what the person's blood pressure is. So let's say you have, if this is, maybe if it's 4, what is the blood pressure if it is 4? If BMI of 4. So what you do is you link it to the line, right? And it gives you this somewhere around 7, right? So I'll say BP is 7 millimeter mercury. Is it millimeter mercury?
It's not millimeter mercury.
Millimeter mercury. So this is prediction. But if we want to reframe this now such that our task is not that we want to get the pressure specifically. We want to know if the pressure falls under high pressure or low pressure. So that is where logistic regression now comes in. That is where logistic regression now comes in. So what does logistic regression do? It uses its function is a probabilistic function, where, for example, this is 0 to 20, right? Yes. 0 to 20. 0 to 20. It compresses 0 to 20 to a range between 0 to 1. Because this is classification now, we want either low or high blood pressure. And what it now does is that, how does it do that? Now I told you machine learning is built on statistical models. It uses, this is one of the equations we use to Z. So, you know the exponential function is a smoothing function. We call it smoothing function because you can get two groups with this. So what it will do is that any value it gets from here, it will apply it to this smoothing function. By the time you apply it here, the values you will get will be between 0 to 1. Then you can now apply a threshold. Apply a threshold, say that maybe for your task now you say anything above 0.7. This is how digital systems work too. When you are converting from analog to digital, after it samples it, it's going to use a threshold and say, okay, where they say 0 and 5. You know it doesn't, where you use maybe voltage now 0 to 5. You know that what it normally does is going to set the threshold, maybe anything from 3.5 above, to take it as 5 high. Anything from 0 to 1 or 2 to take it as low. So that's the same thing that happens here. So you can say anything from 0 to maybe 0.7. I will classify it as what low, which is 0. While anything that falls under 0.7 up to 1, I will classify it as what? High. That is logistic regression. What do I mean by, you ask the question, what do I mean by threshold?
Yeah,
Huh?
threshold.
What we mean by threshold is what I will say is threshold now. Let me say pass mark now. You write jump. 180. If you score below 180, what happened? They ask you say I failed jump. They cannot be admitted into a university. Abi?
Yeah.
So that is the threshold.
That 180 is threshold.
It's a threshold.
Okay.
So it's the standard that we have set. So although 180 is not zero, but anything that is 180 below, you call it fail.
Okay.
You know, in some schools now in China, I hear that in China, if you score below 70, even in some schools in Nigeria, if you score below 70, you are failed.
Even you like.
In Unilag, ba?
People are looking for PhD.
Yeah.
You don't have 4 points.
In your masters. So that is it. See it.
Your masters fail.
You fail. So that is it now. So now, different schools will have different threshold. Some can say 2 points is okay. Some can say 1 point. Some can say 3 points. So it depends on. So that's what logistic regression does. So now, that's where domain knowledge comes in. Maybe with your medical experience, you can say, okay, maybe it's from 0 to 0.6 is okay to classify it under low, and from 0.6 above, you classify it under high.
Okay.
So that's defining the threshold. So anything that falls under or comes under here, we'll call it low. While anything that falls above here, we'll call it high or 1, right? That's the way logistic regression works. Using these exponential functions. And exponential functions are like smoothing functions. There are other functions too. That's